Rapid Revision for GATE Computer Science. This is Aditi Srivastava. In this lecture, we are going to write the Quicksort algorithm. In the previous video, we discussed about the logic behind the partition algorithm, but here now we are going to really write the algorithm, which is very easy if you understood the previous video. If you have not seen the previous video, please head back and watch it and come back here again. Okay, so let's get started and let's write the partition algorithm here. As we have discussed in this this previous video, the algorithm says like this. P is initiated to the pivot element, that is first position. For the sake of simplicity, pivot element can be any number, any position. Okay, then I is incremented here and j comes here. So these are the values, initial values. So let's get started. Partition algorithm. Array has been named as A. P is the initial pointer, that is pointing to the first element of the array, and Q is pointing to the last element of the array. Okay, and we can see it here. We are storing the element value of the pivot element in a variable x. Okay, so we are storing it here and we are initializing it to the I2 pointer first element. Then j is incremented to p plus 1, that is second element, and j goal is the greater people. J will move further if it gets the greater element, and what happens is that if it gets the smaller element than the pivot element, I will be incremented further and swapping will occur among I and j. Okay, so that is the algorithm. So let's write a loop. Okay, let's start a loop. Okay, that will be the condition will be while j reaches the end of the array. Okay, so j reaches end of the array is q. So j reaches the end of the array. What we will do? First of all, if we say that x is the value of the pivot element. Okay, if the pivot element is greater than a of j, the pivot element is greater than a of j. So yeah, we can say like opposite. If a of j is greater than x, a of j, whatever element we are passing by, is greater than the pivot element, so that is the property of j. Okay, so j wants the greater people than the pivot element. So what will happen? It will just move. Okay, so it will just increment j plus plus. Else, otherwise, if it is smaller or less than equal to x, what happens is that I is incremented to I plus 1. Okay, I is incremented to I plus 1, and what happens is that we are getting towards the greater number, then swapping will occur. So we are swapping a of I and a of j. Okay, so we are swapping a of j and also incrementing j, so j plus plus. Now this is done. Then what happens is that, okay, let me help you understand it. I have already told you that I and j had made a compromise. I will take smaller element, j will take greater element. J will be going by incrementing to the right hand side, and whenever it gets a greater number, it will just increment j plus plus. Otherwise, if it gets a smaller number than the pivot element, what happens? It promises to give it back to I. For that, I is incremented by 1, I plus plus, then swapping will occur between ai and aj. Okay, so that swapping will occur. So that happens. So I explained it already. So that will be very easy to you now to write the algorithm. Okay, so in this we have done this, but at the last what happens is that this is our for loop is done, and after that we will swap a of I and a of p. Okay, So after that, at the last we are swapping AI and AP, as we have cleared in the previous example. What happens at the last? I gets the correct position of the pivot element. So here pivot element is here it was at the last it was 5, and here it was 10. So we have swapped it at the last because I is the correct position of the pivot element. 10 goes, and pivot element was 10, so 10 goes to here and 5 is here. So at the last swapping had occurred. So in the similar manner we have written the algorithm. Okay, so this swapping has occurred, and at the end you have to return the position of the correct position of the pivot element. So we are returning I. So that is the partition algorithm. Okay friends, so that was the partition algorithm. And after that, after the partition algorithm, what happens is that we will write the quicksort algorithm. Okay, so you can take a snapshot. I am keeping it still. Okay, and this is snapshot the code. Okay, pseudo code you can say, not the proper code, but I am giving it in order to understand you properly. Okay, so you have to get it. Now we will write the quicksort algorithm. Quicksort algorithm is nothing when you understand the partition algorithm properly. Okay, it's very easy now. So quicksort algorithm on array with starting pointer a p and ending pointer q. If p is equals to q, that is a single element in the array, it is a small problem, it is already sorted, and return a of p. Else you will call else part matters a lot. Okay, that adds to the time complexity of the algorithm. And else let's take a variable m. M is equals to partition apq. Partition apq that will return the correct position of the pivot element. So because here it will return I. Okay, so here it is returning I, that will be loaded onto this m. Okay, that is the correct position of the pivot element. For example, here what the numbers we have taken, here the correct position is 2, so I will be returned 2 and that will be stored in m. Now our task is to perform quicksort on this two sublists, that is to the left of the pivot and to the right of the pivot element. So in the left of the pivot element, what happens? Left of the pivot elements we are applying, suppose this is m has stored 2, so we will apply a p to m minus 1 quicksort, and here we will apply quicksort a to a from m plus 1, this is m plus 1 to q. Okay, so this is our new task. Nothing more or less will be there. It's very easy now. Okay, m is equals to partition apq. Okay, partition apq, m will be stored. Then we have to run quicksort a p to m minus 1. Okay friends, and then after that quicksort a to m plus 1 to q. That is that this is the starting position, this is ending, and this is starting and this is ending. Quicksort on the two sublists, that is to the left and to the right of the pivot element. Okay, then after that we will finally return the array, sorted array of numbers, and that is done. So this is the quicksort algorithm. I hope this you have understood it very clearly. Thank you. Thanks for watching. If you like the video, please like, comment and subscribe. Bye for now. Thank you.